Pulse-heated reflow soldering is a process where two pre-flux solder-coated components are heated by a thermode to a temperature sufficient to cause the solder to melt and flow, and then cooled under pressure to form a permanent electromechanical bond between the components. Here we see the thermode, or hot bar, and the two components to be joined by soldering. The conductive traces of the two components are properly aligned, and the reflow head moves the thermode down to exert pressure on them. Electrical current is passed through the thermode, heating it to a present temperature, which is controlled by thermocouple feedback to the pulse heat power supply. In this view, we see a close-up of the conductive traces, with solder pre-applied to the pads. The traces are aligned, and the thermode exerts pressure on the components during the soldering process. The heated thermode melts the solder pads, reflowing the solder between the traces of each component. The thermode is then cooled, allowing the solder to solidify. Then, the thermode retracts and the process is complete.